In this video, we're going to talk about the domain of function equations. So the domain of a function equation is the set of real numbers that excludes any number that makes the equation undefined or not a real number. So we want to write the domain of each function equation in interval notation. So we start off with a linear function. In fact, this is in slope-intercept form. So I'm going to do a very rough sketch of this now. So we can see this arrow is going to go to the left forever. This arrow is going to go to the right forever. Every single domain value can be found somewhere on this line. So the domain is all real numbers, or negative infinity to positive infinity. In fact, the domain of all linear functions is going to be the set of real numbers. Okay, let's take a look at the next example then. This is what is called a rational function. You have variables both in the numerator and the denominator. Well, a fraction is undefined when the denominator is 0. So let's set the denominator equal to 0. So that's 3. So I know 3 needs to be excluded from the domain. Okay? But there is no other value that makes the denominator 0. So I'm going to shade on both sides of 3 because of that. So now let's write the domain in what's shaded on the number line. Well, we start from negative infinity to 3, or I can be from 3 to infinity. Because I can be in one or the other and not necessarily both, there'll be a union here. Okay, let's take a look at the last example then. This is what is called a square root function because you have variables under the square root. Now, let's review this very quickly. What's the square root of 4? Well, that's 2. 2 times 2 is 4. How about the square root of 0? That's 0, because 0 times 0 is 0. How about the square root of negative 1? Yeah, there is no value that you can multiply by itself to get me negative 1, because negative 1 times negative 1 is 1, and 1 times 1 is 1. In fact, the square root of negative 1 is I. That is a complex number, not a real number. So in other words, I cannot have a negative number under a square root. Otherwise, it's not going to be a real number. Okay, so what do? I'm going to take what's ever under the square root, which in this case is 7 minus 3x, and set it greater than or equal to 0. This avoids having any numbers that are less than 0 under the square root. So solve it. And then divide by a negative 3. When you divide by a negative number, you switch the inequality sign, putting this on a number line. Okay. And then writing it in interval notation. Okay. Now, somebody might be saying, well, Professor King, there's a lot of negative numbers that are in the domain. That can't be possible, can it? Well, let's plug in a negative number in this square root function and see what happens. Here I have a negative times a negative, that's a positive. And when I simplify, notice I have a positive number under the square root. So it's okay to have negative numbers in the domain as long as when you plug them into the function, you do not have a negative number under the square root.